All right, we are going to start simplifying exponential expressions using those laws or properties of exponents that we just talked about with our cute little flip books. So we can use properties of exponents to an exponential expression is considered fully simplified when there's three main things I want you to look out for. There are no repeated bases. And so, no, x in the top, x in the bottom, two x's in the top, that sort of thing. And no negative or zero exponents. All right, so this first one, I noticed that zero exponent right away. Hold on. Students are always like, ugh, what order should I be trying to get rid of things in? I don't even know where to start. And the problem becomes, right, that there isn't a straight answer to that. So a lot of these properties we can use, right, interchangeably. The order doesn't necessarily matter as long as we're doing everything appropriately. And so that can really bug students. So what I like to do is think about what's going to make my life easiest first. So I always try to get rid of any zero exponents right away because I know that those are going to be 1 and I can get rid of those, right? So instead of 2 times x to the 0, this is going to be 2 times 1, aka just 2. So I'll rewrite this as 3 times 2 cubed. All right, and then now we're just evaluating, right? So notice that the cube is on the 2, so we have to carry out, thinking about order of operations, that cubing before you can multiply by 3. So this will be 3 times 8, or 24. This is a quicker lesson today, by the way. I'm showing you 9, I think it is, examples, and that's it. So very exciting stuff. All right, we have b, x to the 4th times x minus 2. So let's see what's going on here. We're going to have, because there's a negative, right, you might be like, oh, first thing I want to give it that negative, put it in the denominator using the that quotient property. But you could keep going with just thinking about this being a product of powers and combine those exponents as well. That way, whatever floats your boat. So I think that way is easier because it becomes 1 step rather than 2. But again, that's kind of up to you. Both will, as long as everything's done correctly, get you to the same answer. So here we're going to have x to the 4. Adding negative 2, right, just becomes 4 minus 2. All right. And then when I carry out this direction, that's just x squared. Right, so we're assuming, if you think back to the properties, this is part of what was in there. We're going to assume all these variables are non-zero because then we don't have to worry about any zeros in the denominator. So FYI, putting that out there. Should have put a caveat in my notes. We're pretending or assuming all these are non-zero. All right, great. Here we have this negative exponent. Then we have a power to a power. So again, kind of whatever floats your boat. Maybe you're like, oh, please, can we get rid of that negative exponent? So this will become still to the 4th power. This can be 1 over x cubed instead, using that reciprocal property there. Now we're going to use the power of a quotient property. We're going to raise the numerator and the denominator to the 4th power. So this will be 1 to the 4th over x cubed to the 4th. All right, so that'll be 1 over, and now we get to use another property. We have a power to a power, so we're going to multiply those exponents, right? And so this will be x to the 12th. So let's go back and just think about what properties we used here, right? So first, we took care of that negative exponent. Then we did power of a quotient. And then we did power to a power. So this is something I call annotating you can think about it like leaving notes to yourself or comments to yourself so that later on when you go back and you look at your notes and you're like, what the heck was I doing here? You've got a little note to yourself, right? You're like, oh, here, right? What happened was I used that power of a quotient property. I can go back to my notes in my flip book and see what that's all about. All right, I'll get off my soapbox. Okay, so here we have 2y cubed quantity squared times y. So first thing I'm going to do is apply that power of a product. So it will become 2 squared times y cubed squared times y. So again, if we're leaving ourselves notes, was power of a product. All right, then we are gonna carry out that squaring. So this will become 4. This will be y to the 6th. Anyone know why that was? Because I used power over power, or power to a power. However, your teacher said, or you, says that. And now we're going to do power of, or just a product of pairs. Just we're multiplying those bases there. So this will become 4, wrong color. This will become 4y to the 7th. All right, I think you can go ahead and tackle E and F here on your own, and then we'll come back and talk about them. Hey, I'm serious. Pause the video, do those problems on your own, and we'll come back and talk about them, okay? All right, welcome back here. Get x to the negative second over x cubed. I'm going to start by subtracting those using the quotient of powers. So of x to the negative 2 minus 3, which is me x to the negative 5th. And because it's a negative exponent, we can't have that. So we take the reciprocal and we'll have 1 over x to the 5th. All right, next one. If I dealt with that negative exponent, hear me out. Right now, this thing would end up as a double stacked fraction, right? A fraction on the top of a fraction, and that would get gnarly really fast. So I'm going to take care of that squaring the numerator first. So this is going to be power of a product, right? I'm going to have 3 squared times x to the negative 3rd squared. Now it's fairly common to have that power of a power within here, like I've got going on here. So this is going to become 9 times x to, we have to multiply those exponents, the negative 6th. And then that's over x to the 4th. Ah! Forgot my x to the 4th over x to the 4th here in this one. Yikes. Here. But we'll just clean this up so it doesn't look like I sneaked it in there because I forgot about it, like I totally did. All right, so now we'll do some subtraction. So this will be 9x to the negative 6 minus 4, which is going to be 9x to the negative 10th, which will be 9 over x to the 10th power. Another common misconception is students will think that a negative exponent means that the base becomes negative, but really it's that reciprocal there. All right, we're gonna get into a little bit gnarlier problems here, but that's okay. We are ready to go. First thing that I'm going to do here is take care of that squaring in the numerator. So this will become 9, a to the 4th, b to the negative 2. So what I did there was when I squared everything, I also applied the power of a power rule because I knew that a squared, quantity squared, I was going to multiply those exponents, and same with the b. Okay, so if you're not comfortable with that yet, you can totally still make that 2 steps. All right, and then this is over 9 a cubed b. So what I tell students is I like to think about this kind of one chunk at a time. So think about the 9's over the 9's, the a's over the a's, the b's over the b's. All right, so when I think about 9 over itself, that's just going to become 1, right? Thanks, that worked out nicely. If I have a to the 4th over a cubed, I can subtract those exponents, a to the 1st. And then b squared over b to that invisible first part will be b to the negative 3rd. And so this will become a over, oh, the a looks kind of like a 9. Oh, man, a over b cubed. All right, 2 more, guys. We've got this. So if x to the 4th y over x to the negative 1st y squared, or y cubed quantity squared. All right, so the first thing I'm going to do is take care of that squaring. So we're going to have x to the 4th y over, again, I'm going to carry out the power to a power as I go here, but if you are still wanting to write that as 2 separate steps, by all means, go for it. And then again, I'm going to think about x's over x's, y's over y's. So I mean about x to the 4th minus negative 2, right? That's going to become addition, right? 4 minus minus 2. So x to the 6th. And remember, this is a y to invisible first power here. So 1 minus 6 is to become y to the negative 5th. And then I know I'll rewrite that as the positive 5th power of the reciprocal. There you have it. Right. And now, last but not least, this monster here. I'm going to start by squaring that numerator and then kind of smushing this into one fraction, okay? So this will look like 4 squared, which is 16. A squared squared will be a to the 4th. B to the negative 3rd squared will be b to the negative 6th. And then we have that b to the 4th power next to it. Next, we just rewrite the bottom, and all I'm going to do here is kind of smush that a. Now what I'm going to do is clean up those repeating bases using power or products of powers. So a to the 4th stays the same. Okay, but I have b to the 6th and b to the 4th, which or negative 6th and b to the 4th, which I can add those exponents and I'll get b to the negative 2nd. All right, and then the denominator, I'm going to have 2. Again, I'm going to combine these a's, so I'll have a to the 6th, and then b to the negative 1st. And then again, I'm just thinking about 16 over 2, a to the 4th over a to the 6th, b minus 2, b minus 1. All right. So what happens here is I'll end up with 8, a to the negative 2nd. Negative 2 minus minus 1 becomes plus, right? So I'll have b to the negative 1st. And so then this will be 8 all in its own sum over a squared b. And there you have it, guys. Ta-da. Oh man, I didn't box off the answers.